Okay, guys, so let's start the today class. Uh, okay, so let me share my screen.
So, Shank, what's going on? Is this still the CCNP Onco class, or what's going on?
Yeah, I will tell you just a second. Okay. So this is again, we have a encore class today and we are starting with our BGP topic, but today class is live streaming on YouTube. And also it is a demo class for some of the students. So some of the new guys joined us today. So let me introduce myself to them. So my name is Shank and I am a triple CCI in CCI's routing switching service provider and data center. I passed my CCI exam way back in 2012 and I have a working experience of around 12 years of industry experience. And I worked almost on all the technologies and solutions, starting with the network engineer to the solution architect, then pre-sales consultant and other stuff. So the new joined guys, related to your questions, we will discuss about your questions in the last half an hour related to any of the technology question. If you want to ask whatever topic I am taking, so you can ask it. Okay. But as this is the live class as well, and also that is the batch of ENCODE that is going on, so just kindly maintain the decorum of the class, and if you have any question, just type it in chat. For the other guys who are old, you can do like whatever we are doing in the previous sessions. So any question before we start? I'm audible, guys?
Yes, sir.
Okay. So let me start with the BGP topic of today. So guys, as you all aware, BGP. So can anyone tell me why we use BGP? What is the use of BGP routing protocol?
It's used on the internet.
What else?
So in OSPF, you can go up to 255 hops, but if you go with BGP, then there won't be any up count. So that is one reason.
What else?
It is widely used for internet.
Yes, sir.
Okay. So the main two reasons of using the BGP, okay, why we use BGP. So there are main two reasons behind that. Okay. The first reason is if you are service provider, then you need a BGP. Okay, because you need to provide your service via internet or via MPLS or etc. So that is the first. The other one is if you are doing multi-homing. So multi-homing means if you are connected to dual ISP. Okay. Then you need a BGP. Okay. Even if you are connected with a single ISP, you can you can use the BGP, but there is not much of the things you can do. Okay, because BGP is basically a path vector protocol. Okay, so means you can change the path and do the load balancing based on attributes or etc. Okay. Then BGP runs over TCP. Okay, and TCP port number 179. So remember this port number. So this is the port number in your IP header. So again, let me tell you, you have your data link header, then your IP header. Okay, so inside that there's a field called protocol field. Inside that, if it is 179, then TCP and then BGP header, and then your data. Okay. And BGP is unicast. So no multicast and broadcast in BGP. Okay. Then it only do triggered updates. Means whenever you got a change, it will do the update. So there is no periodic update with the BGP. Current version of BGP that all over the world is running is BGP version 4. Okay, so any question till here related to this? Okay.
Question, BGP is unicast, you said?
Yes.
Not multicast? Like
No.
EBGP or OSPF?
Related to updates I am talking about. Okay, so if it needs to send, it will send the update on the unicast address, not the multicast.
Oh, got it.
Okay. So next topic we have here is autonomous system. So guys, tell me, what do you mean by autonomous system? These are the basic things which you read it in CCN exam. So tell me, what do you mean by autonomous system? Anyone?
Networks in a group
Mm-hmm.
is assigned to a number.
But what group? Group of what?
Well, autonomous system is the system which is under the control of the single administrator.
Mm-hmm. Okay.
Collection of internet
Mm-hmm.
protocol.
Okay. So autonomous system is basically a group of single administrative domain. Means domain you can say is a company. Okay, either your service provider, they have their own autonomous system. Whenever you register a company, you will get the autonomous system if you want to run the BGP. Okay, then it is also, you can say, a group of routers having similar routing policies.
Well, Shank, I have a question. I mean, you mentioned that BGP runs over TCP port number 179. Can you please elaborate this? And if you can show, I mean, the
Mhm.
process, how TCP 179 is in use. I mean, where.
Okay, so let me complete this topic and then we will talk about TCP. Okay.
Okay, thank you.
Okay, so your autonomous system is assigned by INA. Okay, so everyone knows about INA, right? So that is a central authority which assigns the autonomous system, and there are two type of autonomous system. One is public, which is assigned by INA, or other one is private, which you can use on its own. Okay, now the range of autonomous system is, if we talk about 16-bit, that is from 1265535, and if you go for with 32-bit, then it is 0.0265535.65535. So these are the range, in which private range is from 64512 to 65535. Okay, so this is the private range of AS number. Okay.
So, Shank, when we compare this to EIGRP, which also has AS numbers, we don't have to go through the same process, right?
No, EIGRP, you can use the AS number whatever you want in your organization, and those are private AS number only. Okay, because here you want to talk with the ISP, so you need to take the autonomous system with your public.
Got it. Thank you.
Okay, You can also go with the private as well, but then there is a limitation which I will explain later on. Sorry, just a second. Okay. Okay, so related to TCP, we have physical layer, we have data link layer, we have network layer, we have transport layer, right? And then we have our session layer, presentation, application. Okay, so forgot about these three. Let's talk about the blue one. So here the things are in bits. Data link layer. What is the PDU at data link layer? Protocol data unit.
Frame.
It is frame. Okay. For
Right.
network, it is packet.
IPs. Packet.
And then here it is segment. Okay. So here the things work on the MAC address. Here the things work on IP address. Okay. Here things work either TCP, UDP, RTP. Okay. And then over top of it. So now what will happen is when, and here it is in bits. Okay. So on wire. So what happen is when it makes your frame. Okay. So this is the frame. Then over top of it, it will put the packet. Okay. This is your layer 3. This is your layer 2. Then this is your layer 4. So here it is TCP. And then it will run over TCP. Okay, so this is how the complete packet will form. And then after BGP, you have your data, which includes your session layer, presentation layer, etc. Okay, so this is how things work. Related to TCP, when you create a session, you can do the show TCP brief to check your session. And if it is stuck somewhere, you can do clear as well. So there's a command clear TCP, TCP, and the number. So inside TCP brief, you will get your TCP number. So you can clear your session related to that. Okay.
Hey, Shank, are you saying that, can we say the BGP is a layer 4?
BGP runs over top of TCP. It is not layer 4. It is just a protocol. Okay. Like for example, EIGRP runs over RTP.
So it's a protocol or an application?
Yes, it is. You can say application. Okay. Then your OSPF runs directly over IP. It not uses L4 header. Okay. So this is how your protocols works. Okay. If you want to test the connectivity of your session, the command use is you can do the telnet of your neighbor IP, and you can run with the port number of 179. Okay. And then you can do it. Test of your TCP connectivity. So any question till here? Are we clear?
Yes, clear. Thank you.
Okay. Okay, then what are the connection redundancy type in BGP? Just a second, guys. Okay. So the first one that we have is single homed. Okay. So single home means this is, for example, your company and it is connected to your single ISP. Okay, that is mean by single home. The next one what we have is dual home. So dual home is your company is connected to the single ISP only, but it is connected via two links. Okay. Then the third one we have is multi-homed. Where your company is connected to two ISP either by one router or by two routers. Okay. So either you will get like this or else you will get like this. Okay, this is ISP1. This is your router 1, router 2, ISP2. And then the fourth is dual multi-home. Where your company is working with ISP with two links, or else you have two routers which are connected to two different ISPs. So all over in the world, these are the type of topology you can get and connect with your ISP, any one of these in your enterprise network. Okay, so and it depends on the budget, on the redundancy, your SLA with the ISP, like which topology you are choosing. So any question till here? Okay.
So the fourth one, the dual multi-home, that's the one that we have multiple ISPs, and also we have two links to each country. Okay.
Yes. Yes. Okay.
What about the dual home? You're basically same ISP going to the same company. Just where's the redundancy there?
So it is having only a link level of redundancy. This is called as a link level of redundancy only.
No carrier redundancy, just link redundancy. Yeah.
Okay, and here you are getting linked as well as device level redundancy. Okay, this is your device level, or you can say ISP level redundancy. And here it is not, no redundancy. Okay.
Hello.
Yes.
Yeah. So, for the redundancy, I was thinking maybe, I don't know. I was thinking some company have it this way, whereby router one is connected to ISP1 and ISP2, and router two is connected to ISP1 and ISP2. So there's
So
a
this
cross.
is how actually you are talking, right?
Yes.
Yes. So this is also you can do it, but
Okay.
again, if you go it by this way, then this will be dual multi-home as well. So
Okay.
this is what actually you will get. Instead of two links on the same ISP level, you are doing the cross, right? So this is what you are doing. Okay.
Yes.
So yes, this is also is a variation of dual multi-home. Okay. Sorry. Okay. So next topic is we have two flavors in BGP. One is IBGP, and another one is EBGP. Okay. So guys, what is the major difference between those two? If anyone knows.
Internal, external.
Sorry.
internal and
Internal
external.
use and external.
So internal and external is okay, but what is exactly those?
External is communicates with the internet, and internal is communicates within the
So
Mhm.
basically, the
enterprise.
difference is the AS number. IBGP is same AS number, EBGP different AS number.
So if you have a different AS number, then it will be identified by the external only, right?
Right.
Yes. Okay. So IBGP is basically BGP running between routers in your same AS number. Okay. And here EBGP is BGP running between routers in different AS number. Okay. Then the other difference related to this is its need not to be directly connected. So you can create a IBGP neighborship which are not even directly connected. Okay. And it needs to be directly connected. Okay. By default. You can disable this behavior by two options. One option is this command, disable connected check. Okay. So this command you can run. Otherwise, what is the other option? Anyone know?
EBGP multi-hop.
Yes, so EBGP multi-hop. We will discuss about EBGP multi-hop in next 10-15 minutes.
So when you say directly connected, do you mean physically directly connected?
Yes, yes. So it will be physically directly connected. You need to do, or else if they are not, then these are the two options you have. Okay. Then your TTL is 255 here as well. Okay. There is no option of getting the TTL above 255, and the AD value is 200 here. Here the TTL is 1 by default, and you can change this TTL by EBGP multi-hop. I will discuss it in 10 minutes. Okay, so by this option you can change this TTL value. So it increases basically your TTL. That is what it do. So that you can create neighborship over non-directly connected interfaces. And the AD value here is 20. Okay. So these are some of the major differences between your IBGP and EBGP. Any other question till here? Okay. Yes, Glenn, you there? All good?
Yes, Shank, I'm all good for now. Thank you for asking.
Yeah. Okay. Neighborship condition. Like in what are the things we need to match to form the neighborship in BGP? Okay. So the first thing is BGP version number match. So right now everyone is running BGP version 4. So it should match. It is not like the one way you can run version 3 or other router you can run version 4. So these should match. So by default, if you enable BGP, there it will directly run in version 4. Okay, then in case of IBGP, if you are making a IBGP neighborship, then your AS number should match. Okay, then your hold down timer should match. Okay, and then your authentication password should match if you enable authentication, else it is not needed. Okay, so these are the things that needs to match to form a BGP neighborship. So any question related to this?
So that's both for EBGP and IBGP, right?
Yes, this is this condition, second one.
Yeah, except for
It
the
is,
second bullet. Yeah.
yes, second bullet is for IBGP, rest all is related for both IBGP and EBGP. Okay.
These are, Mr. Shank, these are IP dependent, right? IPs don't play any role as far as contiguous or the same subnet, things like that.
Yeah, same subnet is, yes, that is by default you need to do it in the same subnet. So that is understood. Okay. For new guys, our flow is like first we cover the theory and then we will do the practical. So today I'm just covering the theory itself. So, okay. So how to enable the BGP and what are the basic commands that you need to give when you are doing BGP. Okay. So first command, for example, this is your router. You need to go in your configuration mode and then you need to give router BGP and then AS number. And guys, you can only run one process of BGP. So it is not like OSPF. Okay. So it is not like OSPF where you can run multiple processes. It is when you enable a BGP with one AS number, then you cannot enable another process of BGP on the same router. So only one instance can be configured at a time. Okay, so this is the first command which will enable your BGP, and then you need to specify your neighbor. So this is neighbor, then this is neighbor IP. Okay, and then whatever is your remote AS number and then AS number. So in case of IBGP, it will be same, and in case of EBGP, it will be different. So these are the minimum two commands you need to do a BGP neighborship. Okay. So any question till here, or I will explain it with the diagram of how it goes, or we are good.
What about in the sense of VRF? And can you like use different VRFs with the BGP or it won't work?
So VRF is right now not a topic of BGP as of now, so we will cover it in MPLS.
Oh, okay, all right.
Okay. Then if you need to shut down the BGP neighbor, you can do that as well. Okay, there is a command to shut down your BGP neighbor, and the command is inside your router configuration mode of BGP. You can give your neighbor IP, and then you can give it the shutdown. So you can do it. There is no need of remove the command. You can do the shutdown of your BGP neighbor. So practically in a production environment, I will tell you where we use it. So once I am upgrading this ASR router, okay, which is connected to the ISP internet. So in that case, what happen is in like on the primary one, when we are putting the failover towards our secondary, okay. So in that case, what happen is we need to shift the traffic towards the ASR2. So what we will do, instead of removing the command, we just shut down the neighborship here. Okay, and then so all the traffic which is coming from our LAN side, it is instead of primary path, it goes towards from the ASR2 and then from the internet, and then we done the upgrade, and then we will do no shutdown. Okay. So again, there is no command of no shutdown here. You need to give the no in front of this. Okay, so you need to put no here. Okay, so it will remove this command and your neighborship will be up. So that is a very good command to use in the production as well, where you're doing any upgradation or you need to change your traffic flow.
So if I shut down the interface facing the internet, then that will also help or not?
From which side?
Primary, suppose I'm doing iOS upgrade, so primary I'm shutting down the interface facing towards the internet.
Yes, that's it. That is also you can do it, but again, that is just it will break the neighborship and it will also send the traffic towards your ASR2. But again, there is a functionality present in BGP where you can break the neighborship like this way as well.
Okay. Got you.
Okay. Yeah. Okay. So next is your IBGP source IP address. So what do you mean by that is, what happen is by default outbound interface is used to make the neighborship. Okay. So for example, if this is my R1, R2, R3, and if I need to create a IBGP neighborship between my R1 and R3, okay, so this is what I want IBGP here. So guys, let me tell you, before making the IBGP, you need to have a routing protocol running inside your topology. Okay, so any of the interior gateway protocol you can run, means RIP, EIGRP, OSPF, ISIS. Any of these protocol you can run, so that you will have your R1 have connectivity towards your R3. Then only this IBGP neighborship will come up, else it will not come up. Okay. So what I was telling here is, when by default it is making the neighborship, it is making the neighborship with the outbound interface. So this is the interface E0 by 0. It is used in our topology. Now my requirement is, I want to create the neighborship via loopback. Okay, so via L0 and L0 here. I don't want to use this. So then I need to give the command neighbor, whatever is the IP, and then update source, and then your interface, which interface you need to give. So here in our case, we need to give update source, then loopback 0. Okay, and this is neighbor IP. So any question here?
Yeah, Shank. So what's the reason we need to use a loopback? I know for best practices for IGP protocols, it's not good to use the interface because it could shut down for router
Yeah,
ID and stuff.
same reason. Your
Okay.
loopback is going to be down when your router is down. So it is always the best practice to go with the loopback.
Okay. Okay. And then you mentioned that we need an IGP protocol running in the background before IBGP neighborship is formed. Can you kind of explain a little bit why
Okay.
that's required?
Yes. So what happened here is, you are there in my SD-WAN class, right?
Yes.
Okay, so in SD-WAN, what happened here is, before we doing anything, right, we should have a connectivity with our vManage if we need to do anything on the vEdge, right?
Yes.
So same here the case. Okay, suppose these are my two loopbacks. So R1 should know about the R3 loopback before creating a session, because BGP runs directly over TCP. So before that, it should have a route. Okay. So how R1 get the loopback of R3? How it will get it?
Yeah, I can't get it unless it has it in his routing table, right?
Yes. So either you will run via IGP, which we have 4 protocols, that is RIP, EIGRP, OSPF, ISIS. Okay. So this is what we have, or else you can do static routing as well if you want.
Got it. Got it.
Okay. But in R1 routing table, you should have R3 loopback before creating any of the neighborship.
Got it. So basically, BGP depends on the IP routing table, right?
In case of IBGP. So in case of
Yes.
IBGP, it needs to have the route first before doing anything.
Got it.
So always you need to run your
And-
IBGP before running the IBGP.
And you can't run IBGP by itself.
Directly connected, you can do it, because
Mhm.
directly connected, it has the route. Okay. So if you
Okay.
have a directly connected neighbor, you can do it. But if it is not directly connected, you need a route. And same is the case with EBGP as well. You should provide the reachability if it is not directly connected. Okay.
Okay.
Yes.
Why would you run IBGP if you're running these underlying protocols underneath it?
So to manipulate the traffic, okay, you can do it via IGP as well, but to manipulate your exit points, you need it. Okay, and then this is your ISP1, ISP2. Okay, so here you are running EBGP. This is your one AS, this is some ISPAS, this is another ISPAS. Okay, so here I want my R1 for a particular network, it should take the path via R4 and it should go to ISP2. Okay, so this is what I want. And then for this, for example, for 10.1.1, what I want is it should go via R4 to ISP2. Okay, and then for 20.111, it should go via R2 and then R3 and then ISP1. Okay, so we have path manipulation attributes here in BGP, which we talk it tomorrow. So those are your weight, AS path, okay, all that stuff, local preference. Okay, so these MAD value and all those things. So to change your behavior of particular routing network or towards all the network, that is why what we run IBGP. Okay, the same thing you can do it via IGP as well, but it is then complicated. You need to put routing, this route maps, access list and all that stuff. So your choice, whatever you want to do. It is not compulsory to run IBGP inside your AS number.
Yeah,
Even 90% of cases, companies are not running IBGP. Okay, so for 90% of cases, there is no need of IBGP.
So they're not running, 90% of companies are not running IBGP. Are they doing the path manipulation just with like these regular EIGRP or OSPF? And then
Yes.
on the, I guess on the external side, they're running EBGP. Is that?
Yes. EBGP is again, it is around 99% of cases.
Right. Okay.
1% cases where you have the connectivity with your MPLS provider, where you can run OSPF, EIGRP, and other protocols as well, RIP as well. Okay, so these are the three protocols which you can run with your MPLS provider as well. But again, those cases are 1% only. 99% cases we are running EBGP.
Running EBGP, got you. Okay.
And 90% we are not running IGP. Only in the 10% of cases we are running IBGP.
So
Okay.
I guess it really comes down to is what the company is comfortable with, or what I guess what the generic engineer is comfortable with, or is it a cost preference, or how does that come into determination?
Sorry, didn't got your question.
Like, what's the determination behind it? Does it depend of what protocol you're running? Like, does the company decide it, or is it more of a cost factor, or?
No, it is not related to any of the cost factor, but again, whatever your solution architect will decide or depends on your application as well. Okay. And how you want to go with the flow. It is easy to like, it just if you are running, see, normally in the right now people are running with 3 tiers, right? Where they are using these things, because in 2 tiers where you have only core layer and access, core and distribution and access. So those topologies are directly, they are running the routing protocol inside, like for example, VXLAN, ACI, like that. Okay, so there is a concept of spine and leaf in those things. But in 3 tiers, you have core, distribution, and your access. Your access is purely L2. Your distribution is where you have marking of L2 and L3, like your SVIs and all. And the core is directly routed. Okay, where most of the time you will see EIGRP protocol, and then core is connected to your MPLS routers and towards internet router via your firewall or etc. Any of the firewall we can use. Okay, and then here we are running with EBGP. So these are the use cases or design most of the time.
Excuse me. Can you move back to the R1, R2, R3?
Mhm.
Why do we need? Yeah. Why do we need IGP or RI? I mean EIGRP or OSPF? Why can't we run IBGP itself?
It's
To
your
come.
choice. You can run IBGP as well. If you want to run IGP only, you can also run that. But if you run IBGP,
Mm-hmm.
then if, for example, here between R1 and R3, okay, if you want to
Mm-hmm.
make a neighborship of IBGP, then these are not directly connected. So you should provide the reachability of R3 to R4, R1 before running the IBGP. Okay.
So, Mr. Shank,
And
I have two questions. What is the need to create an IBGP relationship between R1 to R3?
Mhm.
If R1 has a neighborship with R2 and R2 has a neighborship with R3,
So why should I create the two neighborship? I would just create a one neighborship R1 and R3. That's it. And my traffic will flow whatever the link it has.
okay, okay. So that's a good point. So
Mm.
I had another question. So if we implement EIGRP OSPF for R1 to form a relationship with R3, right?
Mm.
Seems like you mentioned that IBGP has an 80 value of 200,
Mm.
right? So I remember in the beginning you said like 80 values are most important, then is,
Mm.
cost. So
So
if
your traffic is going via whatever is the IGP you are running, okay? But you have a BGP table which is different from your routing table. So BGP of IBGP is, that's why it is 200, because they want your traffic to flow via shortest path. For example, let me tell you the scenario. So if you have R1, R2 and R3, okay, and here it is R4 and R5, which is also connected to R3. So now I want my IBGP neighborship between R1 and R3, okay. So this is how I got the neighborship. But now what is my actual traffic flow, from where it goes? So for example, if I am running OSPF, okay, so OSPF, what is the metric of OSPF?
cost,
Okay, so for example, the cost here is, for every ring it is 10. Okay, so it will prefer the lowest cost or highest cost.
the lowest cost.
Okay, so it will prefer this route, this way. Okay, so when you send your traffic from R1 to R3, it will go
Mhm.
via this way. So that's why they put the metric of IBGP to be higher, so that it will not influence your routing packet. Okay, your routing traffic. So IBGP or EBGP, what we are using it to put the manipulation on our paths. Okay, I will explain you later on when we do the attributes how we manipulate the paths. If I want to go the traffic via this way, so how we can do it. So that is what I will tell you later on.
So are you saying that right now OSPF is a clear winner, right, between R1
Yes,
to
in
R3, right?
routing table, you will get a route via OSPF.
Okay. So then if you have a BGP IBGP routing table or IBGP table, are you saying the IBGP table has higher priority than the regular IP routing table?
No, no, no. Everything will depends on your routing table. Your traffic is always go via routing table. Okay.
Okay, so if you do path manipulation for
Mm,
IBGP,
mm.
are you
Then that
gonna
is yeah, that is a different case. Then I will
then
explain
you
you.
are able to make IBGP better than OSPF? Is that the idea?
That is not 100% true, but right now if I explain, it will take around 1 hour.
Okay, okay.
So
No rush, Hank.
let's
If
say,
you
so.
could explain
Yes,
it later, then that's
I
fine.
yes, yes, I will explain it, but again, do not worry about that. So here you will get the OSPF, the route via OSPF, the route via BGP as well. But again, the AD value of OSPF is 110.
Mm-hmm.
The AD value of BGP is 200. Okay. So
Yes.
again, your route will be preferred via this one only.
Yes.
Okay, but later on I will explain you how you do the path manipulation via BGP attributes.
Okay.
Okay, so this is what we have here. Okay, any other question related to this?
Questions? Hello.
Yes, tell me.
Yes. So the configuration you gave to us, so I want to know, is that the only configuration for IBGP?
So again,
Because
the
I know.
configuration is, see, let me tell you. Let me show you with one of the example. Okay, so this is the loopback address 1111/24/2222, because right now our lab is not ready. I'm doing the theory today. Okay, and then here it is 0 by 0, E0 by 1, 0 by 1, 0 by 0, and this is the network 192.168.10.1/24, 192.168.20.1/24. This is .3.2.2.1. Okay, so first of all, you need to run your OSPF inside it. So router OSPF, whatever the process ID, and then you will advertise your network. So here I have on the R1. Okay, this is what I am doing it on R1. So here I will first advertise whatever the networks I have. So 192.168.10.1.0.0.0, and suppose everywhere I am running area 0. Okay, so my whole topology is in area 0, just to make the thing simple. And then I will advertise this network as well. Okay, so this is what we got it on R1. Then after doing the OSPF, I will start with my BGP configuration. So again, same type of configuration I will put it here on R3 as well. Only the difference is inside the network command, the subnets change. Okay, so 192 here you will advertise 20.1 and you will advertise 2222. Okay, so this is how you advertise. So same configuration we will do on R3 as well, and similar way the configuration we will do on R2 as well. So here we will advertise our network as 192.168.10.1 and the network 192.168.20.1. So this is what we advertise it here. So this is related to OSPF. Okay, so OSPF you need to run on every router. But now BGP configuration, I will only need to do it on R1 and R3 if I need to form the neighborship, IBGP neighborship between R1 and R3. Okay, so I just need to do the BGP configuration only on R1 and on R3. On R2, I don't need to do any of the BGP configuration. We don't need it. Okay, so on R1, we will give the command router BGP, whatever the AS number. For example, my AS number is 10. Then, sorry, neighbor command. Neighbor. Okay, suppose I am creating the neighborship via loopback. Okay, so neighbor, my remote neighbor. So remote neighbor is 2222 and then remote AS. Okay, so right now I am doing IBGP. So my AS number is same, both side. Okay, so here also AS number is 10. Here also AS number is 10. Okay, so remote AS is 10. And then you need to give the command a neighbor 2222 and then update source loopback 0. Okay, and then we not need to give multi-hop command. Why? This is not needed. Can anyone tell me why?
255 is the multi.
Because this is not
Because
TTL
TTL's
size is
IBGP.
255.
yes, because of my TTL is 255 already in IBGP. So this is not the EBGP. That's why I don't need to increase any of my TTL. My packet will go via with the TTL of 255. So it can traverse up to 255 hops. Okay, so this is the complete configuration we need to do in this case. So this is what we do it on R1. Same type of configuration we will do it on R3. So again, router BGP, whatever is your AS number, and then again it will be same AS number, neighbor. Now the neighbor is 1111 and the remote AS is 10, and then your neighbor 1111 update source loopback 0. Okay, so this is the minimum configuration you need to do. That's it. And Glenn, to answer your question, this will not add your 1111 and 2222 in the routing table as a BGP route, because we are forming the neighborship. We are not advertising any of the route here. Okay, so to advertise a route in the BGP, the command is starts from network. So you need to give the network address and then with your mask.
Got it.
Okay, so after you give this command, your network is advertised via BGP. So it will show you via B, but again, it will show you via O as well. And that is preferred. Okay.
Yep.
So any other question related to this example? Okay, got it.
Awesome teaching.
Okay, then multi-hop I already told you. So let me explain you in more detail. So EBGP multi-hop. So we need this command only in the case of EBGP. It increases your TTL value. Okay, and you have an option to go from 2 to 255 because 1 is by default. Again, you can give it via 1 as well. It's your choice, but there is no need of giving it 1. So the command is in the BGP router mode. You will give neighbor IP and then EBGP multi-hop. Okay, and then whatever the value you need to give, it will increase your TTL by this value. So this is actually the TTL value which you want to give. So here, if I am doing it, okay, so from R1 this interface, okay, to loopback, if I am doing it, so what is the TTL value I need to give? Tell me.
Can you repeat that?
From the R1 this interface to loopback interface, I need to create
2, right?
EBGP neighborship. So what is the TTL value I need to give?
2.
Yes, the TTL value that I need to give is 2. Okay, so this way it is done for R1, R2, R3 loopback. So here it is 3. Okay, because this again 1 hop, 2 hop, and then the third interface.
No, Shank, I have a question. I mean, are we counting when the router leaves that interface, that is also a hop?
So basically, let me tell you, because that will confuse you. So the best way to count here is just count the links 1, 2, and 3. Okay. So do not worry about hops and all.
Because hops, I mean, wherever I have read,
Yes.
because if I count the hop, I believe that also always create a misconception in my
Yes,
mind.
yes, definitely. So always remember to go with the links.
Because that loopback is not, I mean, that is directly connected to R2. I mean, if I am giving multi hop 1, that should work, because you are that interface is directly connected to R2. It's not
Yes,
leaving the hop, right? I mean, adding any
yes,
hop.
yes. So again, if I create a topology like this, R1 to R2 to R3, and then I am creating a with loopback of R1, okay, towards loopback over. So here the things will go 1, 2, 3, 4.
Correct.
Right? So do not worry about hops. Just always focus on links.
I mean, if I will go by hop, it should be 3, right? R1,
Yes,
R2, R3.
yes, yes. It will make a confusion. So this is again the good way to think. And one more, not related to this, but let me tell you. In switches, okay, when you do the calculation of your spanning tree. So for example, here, my all links have a cost of 10, 10, 10, 10. Okay. So now to tell like this is my root. Okay. So here it is DP, DP. It is root port. It is root port. Okay. And now for this switch, okay, 1, 2, 3, 4. So for this switch, if I need to reach to root, okay, so how you will do it? Okay, so there is a method let me
Okay.
tell you, because this is off topic, so I'm not taking it just 1 minute. Just create one device in between and then divide the link between two these. So again, the cost here is from 5 and then here from 5. Okay,
Mhm.
and then it will go add this cost to this cost. Okay, so again here it is 15,
15.
but again, and here 5, then 10, and then so here 25.
Mhm.
So the cost from where it is going towards that, it is DP. Then this will become your root. So like that way you will form the things.
See, one question again. I mean, here you have chosen why you have chosen this path. Just because, I mean, you have to
Low
choose
cost.
one. No, I mean, you just told us that just add one device over here. You could have added one device in the lower link as well, right? I mean,
Mhm.
just
Yes,
in
yes,
order.
yes. This is also we need to find it out. But again, and due to time issue, I'm not finding it out.
Mhm.
Okay. But
Or
again, this is
maybe,
again a way.
or maybe it's a random choice. I mean, you from the two you can choose any of the link and add a device over that.
See, for this, I need to find the port, and this is also I need to find the port. So in my next step is to put the device here, and then I
Uh-huh.
need to find which link is blocking. Okay.
Uh-huh. Uh-huh.
So this is how we need to do it. So this is another one of the example that I am telling you. Anyways, let's come back to BGP. Okay, guys. So related to your multi-hop, any other question you have? Okay. So let's take a 10 minutes break before we come back again, and we will continue our topic for today. Okay. So
Hello,
let's,
hello, Shanks.
yes.
Yeah, so something just came up my mind now. So in a situation where you don't know the quantity of, like, you don't have an idea of how many of away from your router. So what do you do? What do you configure?
So you need to ask from your service provider. Okay. You need to ask from your service provider.
Or they'll tell you the hops.
Yes, he will tell you the TTL value that needs to put. But again, inside the trace route, you will not get the complete path, because there is a command which can disable the trace route from the path. So that I will discuss in MPLS when we talk about MPLS. You will not get
Thanks.
the topology of your service provider. But in the cases I have seen, 90% cases, it is directly connected with your service provider. Okay. So this command is not needed. 90% cases you will form the neighborship with your directly connected router. So this is your ISP router, this is your company router, and directly connected interface. So he will give you the IP from which you need to form the neighborship. Okay. So let's take a 10 minutes break, and we will back exactly after 10 minutes. Okay.
Sounds good. Thanks, Shank.
Thank you.
Thank you, Mr. Shah.
Come on, the mic, please.
Okay, guys, so let's start again. So am I audible?
Yes, sir.
Yep, can hear you.
Okay. My screen got stuck. Okay. So let's start with the other next topic, which is EBGP next hop problem. So let me tell you the problem first. So the problem is when EBGP router sends update to its IBGP neighbor. Okay. So it will not change source IP. Okay. In update. So your IBGP router is not having a route towards the router that EBGP is sending. Okay, so let me tell you with the example. So this is my AS 65535. This is my AS number 65. Okay. So for example, this is the network that it is advertising, R4. So when it advertises this network to R3, okay, so it will send the update like this. And this is, for example, here the IP is 1.1.1.1/24. Okay. So it will send the, okay, this is NAN 111 via 1111. Okay. Now when it sends it towards R3, R1 not have the route towards 1.1.1.1. R3 know about it because it is directly connected, but R1 not know about it. And it will get the route like this. Okay. So that is a problem. R1 not know about that, and it is getting via 1111, but it is doesn't know about this network. So this will create a traffic black hole. Your traffic will not pass towards R3. Okay. You got my point? And here, for example, we are running 192.168.10.1. So
So do you
now
mean to say instead of
putting it
R1, yeah, 192.168.10.1, R1 is pointing to 1.1.1.
1.1.1 because R3 is not changing your next hop.
Oh.
So there is a command which is next hop self. Okay. And you will give this command. After you give this command in the neighbor statement, R3 will change the next hop to its next hop. So R3 will change it. Now you will get the route. Okay, 10.1.1.0. If you need to send traffic to this, just send the traffic to me. 192.168.10.1. Okay, and R1 knows about this network via Via what?
IGP.
So it
IBGP.
knows it via IGP
Mhm.
or static routing if you have configured any of the way. Okay. So it sends when it needs to send the packet to it. It will send it to R3, and then R3 knows about this network, so it will send it to here.
So, Mr. Shank, since IGP, you need IGP anyways. If we implemented OSPF between
Mhm.
R3 and R1, could you redistribute
Yes.
as well? So you would not need to do next stop. Is that fair statement?
Yes, you can do it, but again, with the ISP, you are running the BGP only. Your ISP is not running the OSPF.
Yeah, understood that. I was saying, but ISP is R4, right? R3 is company router. Isn't that correct?
R3 is company router, okay?
So if can we redistribute the EBGP network at the interface of R3 into the OSPF network between R3 and R1?
You can do it like that way as well. You can do the redistribute. But again, it is better to just give this command. That's it. Because you have
Okay.
the functionality inside BGP, there is no need of doing the redistribution and all. Okay.
Got it. Got it. And in this example, Mr. Shank, when you were saying 10.1.1.1 via 1.1.1.1, right? That is because you formed a direct neighborship, direct IBGP relationship between R1 and R3, right?
Yes. So
Okay.
between R3 and R4, it is EBGP, and
Yes.
this is I am showing you via dotted lines. So
Yes.
guys, in our network world, whatever is showing via dotted line, that means virtual connection. Okay. So that is not a direct link, right?
Okay. Thank you.
Means you are getting your physical path is via this only, R1 to R2 and R2 to R3. It is not directly connected. Okay. So between R1 and R3, we have IBGP, and between R3 and R4, we have EBGP. Okay. Next topic we have is BGP split horizon rule. That is the most important topic of BGP. So what this rule is do? First of all, this rule is used to do the IBGP loop avoidance. Okay. So via this rule, you can avoid the loop. So now what this rule say? Routes which you are learning via IBGP, okay, are never propagated to other IBGP peers. Okay, but you can advertise to EBGP if you want. So let me tell you what does it mean. We have R1, okay, we have R2, we have R3, we have R4, and here, for example, I am making IBGP neighborship directly. Okay, IBGP via R1 to R2. I have IBGP between R2 and R4. Okay, I have IBGP between R3 and R4. And I have IBGP between R1 and R3. Okay, so now this is the network 1.1.1.1. And also, for example, I am making IBGP between R2 and R3. Okay.
So in that case, we need to implement IGP, right? For between R2 and R3.
Yes.
Yes.
Yes. Yes. So forgot about RGP as of now. we need to implement it. That is correct. But let me explain you the other thing. So now R1 is advertising this loopback. Okay, this is one network, one row, 1.1.1. So R1 will advertise it to its IBGP neighbor, right? So R1 will advertise
Yes.
this to R2. Okay, and R1 will advertise to R3 as well. But now what will happen is R2 will not advertise this 1111 to R4, and R3 also not advertise to R4. Okay, so whatever route you will get via your IBGP neighbor, you will not advertise to any of the IBGP neighbor. That is what rule says. Routes which you are learning via IBGP are never propagated to other IBGP peers, or you can say neighbors. Okay, but
So it will
you,
drop the packets.
so yes, so R4 not have the route towards 1.1.1.1. So if R4 needs to send the traffic to R1, it's not able to do it. Now, why this is happening? See, if that rules is not there, so what is happening is R1 will send the traffic to R3. Okay, R3 will send it to R4. So R4 is getting 1111 via R3. Okay, and then R4 will send it to R2. Okay, so now R2 is getting this route 1111 via R1 as well, and R2 is getting that route via R4 as well, which is wrong, right?
Loop prevention.
Yes, it will create a loop. So unless until your TTL got expired, it will form a loop. So that's why this rule will not send your IBGP route to other. Whichever you learn the via IBGP, you will not able to send it, okay, to any of the IBGP peer. Okay, now solution. So we have three solutions for this. One is you make fully mesh IBGP. So what do you mean by fully mesh IBGP? R1, R2, sorry, R2 here, R3, R4. Okay, this is what we have right now. So you will create your IBGP neighborship here with R2. R1 will create IBGP neighborship with R3, and R1 will create IBGP neighborship with R4 as well. Okay, so this is what it needs. And now R2 also need to create IBGP with R4. R2 needs to create IBGP with your R3, and R2 also needs to create IBGP with R1. Same case with R4, it will create it with this. It will create it with R2, and it will create it with R1. Okay, so your total number of IBGP neighborship, how much?
-1.
So
10
it will,
times n minus 1 over 2.
yes, this will be the case. So here in our case, 4 minus 1 by 2. So it will be 6. Okay, so as you increase your router, your neighborship goes increases a lot.
So here, I guess what we're saying is that every router, let's say R1, will be forming with the other three, IBGP with the
Because
other three, right?
because why we need this? Because R4 not having the route of R1. So how it get it? It will get only when it creates your IBGP neighborship with R1, right? So in the case, your every router should be full mesh with other one.
Yeah. Hey, on the number of membership. So let's say, are we saying that every router will be forming IBGP neighborship with the other routers except itself, correct?
Yes.
So in this case, it will be 3, right? So R1, unless I'm missing something, will be
I'm telling about the total number of our IBGP neighborship in topology. Okay. So that will be 6. If you count it 1, 2, 3, 4, 5, 6. So with
Shank, and if I'm just wondering if we have the route reflector, another solution for this as well.
No, your voice is breaking, Luis. So can you explain again?
I'm going to write it.
Yes, yes. Please write in chat. Jagnesh, I will
okay. So hey, Shank, I just
explain.
want to make sure I understood this neighborship correctly. So that's actually the total number of neighborship, not only just from one router's
No,
perspective.
no, no.
Right?
That is not with one router. One router is whatever you have the n number of router. You can do this n minus 1.
Yep. Okay. Cool.
So n minus 1 is with your router only, and total number is n minus 1 by 2.
Cool.
Okay. So that is what is route reflector another kind of solve? Yes. So I'm talking about those. Give me a second, Luis. And Jagnesh, we are going with our course format. So again, I will explain you all those things, but those are not the topic of today. But load balancing, I try to get it today. Okay, so this is the first solution. Okay, full mesh, or you can use BGP route reflector. So that is a another option.
So Mr. Shank, before we go to the route reflector, the fully mesh IBGP solution, you already showed us how to configure it, right? Like previously, so we should be good there, right?
Yes,
you
yes.
just create IGP relationships, and then you have R1 and R4 form relationship. Now we are good, right?
Yes. So when you formed it, you need to advertise via network command, the networks.
Yes.
Okay, so then it will be able to do it.
Okay, got
So
it. So you got to do the neighbor command first, and then the network command. Got
yes, network command is used because I need to explain it, but in 10 minutes. So, but again, network command is used to advertise the network in BGP. Okay. So related to route reflector, that is not the topic of today, but again, let me just tell you in brief. What happened here is R1, R2, R3, R4. Okay. So R1 will be selected as a route reflector, for example. So now R1 will make IBGP neighborship with every other router only. So I1 will make IBGP here. This R1 will make IBGP here, and R1 will make IBGP here. Now, if you need to advertise any of the network on anything, the update will first go to R1. For example, R3 needs to send. So update will go to R1, and then R1 will advertise it to other one. So if it needs to go to R2, it will advertise to R2, and it will advertise to your R4 as well. So that is how we reduce the neighborships. So anything, any update anyone needs to do, it will go via R1. Okay, but again, this is control plane traffic. Guys, always remember there's a difference between control plane and data plane. Okay. So let me tell you what does it mean. Your update, for example, here, let me use the other color for data plane. So for example, data plane is green. Okay, so now what happened here is R4 advertise its network. Okay, so it advertised to R1 and R1 advertised to R2. So this advertised to R1, R1 advertised to R2, and R1 advertised to R3. But again, as you guys know, what we are running in IGP, we are running, for example, OSPF. So if we have a direct path, okay. So now my data plane will go directly. My traffic from, if I need to ping from R1 to R2, okay. So my data traffic will go directly. This is my data traffic flow. And in the white, this is my control plane traffic. So my control plane will always go to R1 first. and then from R1 it goes to R2 and to R3. Although route reflector I will tell you on detail later on, but this is just the basics. Okay, so your control plane traffic will go via your route reflector, and your data plane traffic, it will go directly if you have direct path.
It's kind of like the DR BDR, right? For OSPF.
Something like that, you can say. Okay, so it will go on direct path. And also in last class of our CCI demo class, I explained route reflector in detail. So you guys can watch it. It is freely available on YouTube as well. So you can watch it on that as well. And otherwise I will take the route reflector topic later on in our class. So, but again, you got it. So this is the second option we have. Okay. And if you don't want to go with this other option, then there is a third option as well. The third option is BGP confederation. Okay, so this is again one of the concept where we breaks our AS into sub AS. So now here what I will do, R1, R2, R3, R4. So now instead of doing that, what we will do is we'll break it into AS. So this is one AS. For example, AS65535. We can give the private AS number inside those. Then this is my another AS, which is AS65536. Okay, and then on the top, my whole company, I have one AS, which is, for example, AS number 10. So now what will happen here is inside those, if these are two different AS, then this R4 and R3 are EBGP and or IBGP.
EBGP.
So now they become the EBGP pair. So now we don't need this rule because now these are no longer EBGP. So this is what we called as BGP confederation. Okay, and here they are IBGP. So it doesn't matter because only the single IBGP is there. So it will send it. Okay, so this is the third option. So these are the three options by which are the solution of your problem.
So I'm sorry, Mr. Shang. So on the BGP configuration, if you can zoom in. So in this case, let's say R2 advertises a route. It'll send it to R3 since it's directly connected.
Yes.
It'll also send it to EBGP to R1 via EBGP. Is that correct?
Now R1 is getting it via EBGP. So it will send it to R4 because that is not a IBGP neighbor. That is a EBGP neighbor. So there is no possibility of any loop, right? EBGP loop prevention. Let me tell you the EBGP loop prevention as well. So EBGP loop prevention happens through, anyone knows?
AS path.
Yes. Loop prevents through AS path. So as soon as you got the update, you will add it your AS number. So now what will happen here is R2 when sends the update. For example, R3 needs to update its loop back, okay, to R1 and R4. So what will happen is when R2 is sending, R3 send it to R2, R2 send it to R1, R1 send it to R4, okay?
Yes.
And R3 also send it to R4. Now tell me, R4 will take the route from R1 or from R3?
From R1, right?
Any other answer?
Sorry, what did you say? R3 will learn
It
route
will
from
take it from
R4.
R3 because R3 has a better path.
Yeah.
No, I'm sorry. Take it from EBGP because EBGP has a lower AD value.
Yes. So EBGP AD is 20 and IBGP AD is 200. So it will take it via R3. Okay. So now but I am explaining you a different point. So now what will happen here is when R2 sends that update to R1. So when R2 sends to R1, okay, it will send it like this is the network, okay. Guys, can you please put your mic on hold who are not speaking? Okay, thanks a lot. So it will send it. Okay, it will add the AS number as well. So it will add the AS number 65536. Okay, so this is the route and this is the AS number that is added to your route. So now what will happen is R1 get this via R2 and it will get the AS number. Now R4 also getting the route. Okay, and R4 also send it to R1, right? But again, before checking the AS number, it will check the AD value. So, but again, if you have a loop, what happen here is if you are getting the same route via another AS, but it is having this AS number, it will drop it. Okay. So let me explain you better via another topology. AS1, AS2, AS3. Okay. And this is my R1 network. So it will send it to this. So R2 have this network with AS number of 1. Okay. And R2 send it to R3. Okay. So now when R2 send it to R3, it will append the AS. So first of all, it is 1 and then R2 will add its own AS number. Okay. So which is 2. So now R1 send it to R2, R2 send it to R3. Now R3 will send it again back to R1 because it has a link, right? So now when R1 get it, okay, it will check 1111 and it is coming from AS number 3, from 2, from 1. Okay, so these are the AS number. But it see, okay, it is having the AS number 1, which is my own AS number. So it will drop it. It will not accept this advertisement.
Oh, got
This
it. Okay.
is how it prevents loop.
That's for
In
EBGP loop, right?
yes, yes, that is how it will prevent loop in EBGP. And for IBGP, you have this rule to prevent the loop. Okay, so let me do the screenshot of 2. So one screenshot, then this one. Okay, any question related to this?
Mr. Shan, can you zoom into the BGP configuration, please?
Yes, tell me.
I just want to take a quick screenshot too. A little bit out.
Just a second. Okay.
That's perfect.
I have a question on number 2. Please scroll up.
Good. I'm good. Thanks.
Okay. So next topic is BGP authentication. So BGP between the two neighbors. Okay, R1 and R2, you can enable the authentication on a link so that you will be able to connect with the legitimate neighbor. Okay.
Is that for directly connected and virtual connections too, like via loopback?
Yes. Any of the BGP neighborship, whether IBGP, EBGP. So it only supports MD5 authentication. Okay. And on the per neighbor basis, whether it is IBGP, EBGP, doesn't matter. So the command, is in the router mode. You need to go in the neighbor command, your neighbor IP address, and then password, and then whatever the password you need to give. Okay, password, and then you need to tell this password to your ISP, or your ISP will tell this password to you. and then you can form the neighborship. So again, I have done this as well in production, where I need to talk with the ISP over the phone, and I need to ask the password, like what the password they configured. Then he gave me the password over my official email ID, and then we configured the password at our side. So that is how the things work. Okay, any question related to this authentication? Okay. So next is BGP tables. BGP is a long topic. We're not able to finish even in 2 days. So we will take 3 days to complete BGP. And then after BGP, we will do the redistribution. And then after that, we will start with MPLS. And for new student, I already covered the OSPF class, but I will see like how many of the student will enroll, and then I will take the OSPF class again. And if any of the old guys want to join, you can join it freely, no problem. Okay, so BGP, we have 3 tables. One is neighbor table. So it shows all the neighbors, okay, all BGP neighbors. To see this, the command is show IP BGP neighbor. Okay. Next table we have is BGP table. So it shows you all attributes that you configure, all attributes you configure, and your next hop, your weight, local preference. So these are all attributes. Okay. Next hop, then any of the MAD you configure, etc., etc. Okay. Your origin, like that. So the command to see it is show IP BGP. This is the only command to see this table. And then the third one is, of course, our IP routing table, which has your show IP route, or you, to be more granular, you can go with show IP route BGP. So it will show you only the BGP routes. Okay, so these are the 3 tables we have. Any question related to this? Okay. Then we have BGP address families. Okay, so we have AFIs. What are AFIs? These are address family identifier. So we have 3 type of AFI. One is IPv4, another one is IPv6, another one is L2 VPN. Okay, and the number of these AFIs are 1, 2, and 25. Okay, so this is some CCI stuff I am telling you. Okay, and then so you can run like whatever address family you can run. Okay, and you can run it multiple address family on the same BGP process as well. So the command is, for example, here is address family, and then you need to give your AFI, whatever is the AFI. So you need to give either IPv4 or else you need to give IPv6, or else you need to give L2 VPN. So this is what we use in MPLS. Okay, L2 VPN. IPv6, you guys know IPv6, and this is related to what we use it in our this course, means in this BGP. Okay, IPv6 I will explain you when we do the IPv6. L2 VPN is not a part of RNS, or you can say ENT course. So this is actually used in service provider course or service provider environments. Okay, but I will give you some of the basics of it as well. Okay, anyways, so these are my address families. Then inside address family, you have SAFIs. So these are your sub address families identifier. So it is present in all of your address family. So IPv4 also have it, IPv6 also have it, L2 VPN also have it. Now what are these identifiers? These are unicast. One is multicast. Then another one is VPLS. And then another one is your VPN with MPLS, which is your VRFs. Okay, and then they also have the numbers associated with them, which is 1, 2, 65, and 128. Okay, so every family have these identifiers as well. So for example, IVv4 also have it. Then your IPv6 also have it. And your L2 VPN also have it.
So what is this VPIS?
VPLS. This is your layer 2 MPLS. Inside layer 2 MPLS, we will use it. Okay. So this is again for MPLS in service provider. We will use it again. This is MPLS, but this is part of your ENT syllabus as well. Multicast is your part of CCI ENT, and unicast is part of your core NRC. Okay. So this is how the things, and this is CCISP, and this is CCI. This is again NCore, not in NCore, NRC, and then you have it in CCI ENT as well. So this is how the things have. So we will cover this. Let me tell you what all we will cover. So we will cover unicast for sure. We will cover multicast, and we will cover this VPN MPLS as well. We will cover IPv6. We will cover IPv4. So these all we will cover. L2 VPN and VPLS, we will not do it because those are part of your CCI service provider. But again, if you want, I can just explain you in 10-15 minutes what are those.
So,
Okay.
so Mr. Shank, really quick, the last time you brought up address families was in EIGRP named mode, right?
Yes. So those are the same thing here as well.
So yeah, but I don't understand, like, what is the, do we use this to create neighborships? I'm a little confused.
Yes. So now again, let me tell you.
Where?
When we use class A address, class B address, class C address. Okay, these means you are using unicast. And when you are doing your multicast is not multicast update. Okay, multicast is what the multicast topology we have. Okay, where we use class D addresses. Okay, to create the topology. So when we do the multicast topic, then you will get it in more detail. So do not worry till then. So those are your multicast. Okay.
So these are, hey, Shang, these are the numbers when you listed 1, 2, 65, whatever.
So these are the protocol numbers which we use.
Yeah. So those are something we manually identify.
No,
or
no,
those
no,
are
no, 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 no. You
marked
just
for
need
us?
to give the name. So if I need to enable the unicast family, the command is, let me tell you the command. So the command is address family
IPv4.
IPv4, and then you will give the keyword unicast. If you need to enable the multicast family. So now if you form the neighbor here, okay, that will be unicast neighbor.
Yeah. But I thought BGP only worked in unicast though. Is there multicast there?
BGP works in all these address family. See here, these are the different combinations you can create with BGP. It is a very robust and very powerful protocol.
Right.
Yes. So it will work in multicast as well, which is a part of your CCI ENT. So
sure. Okay. Can you give an example of multicast, please?
So multicast is again when you're using the class D addresses. For example, my topology is like this. But again, I need to explain you a lot of multicast addresses. So again, let me see. First of all, you know about what is multicast. Multicast is when you have either
Multiple
one sender
nodes.
and multiple receivers.
Right.
Like your stock ticking app or like your broadcast TV, IPTV, right? Where you have your multiple receivers and your source is one, for example, and then what you are doing is over the multicast address you are sending it. For example, I am sending it over 225.110. Okay, so this is class D. Okay, which is in my multicast class. So again, there is a lot of concept that I need to tell you before we do it the multicast. But again, we have the multicast topic in CCI Enterprise. So we will, at that time, we will do it. Okay. So if you want to form the BGP neighborship over the multicast address, which is like this, then we will use the inside address family IPv4 multicast. It will not form neighborship in unicast family. Okay.
Okay, sorry, Mr. Shank.
So
Sorry. Please, can I just ask this? I also want to confirm, do we also have any address family, like maybe VPN version 4 address family?
So again, inside this VPN MPLS, we have version 4 and version 6 and multicast as well. But do not go in that much detail as of now. Okay, so but it is there inside your this one.
Okay.
Or
Thank you.
else, let me tell you in a opposite way. So if you are running with your VPN with your IPv4, okay, this is your IPv4, and you are running inside that. I told you every sub identifier is running with your address family identifiers. So when you are running your this with IPv4, it is then VPN v4. When you are running it with IPv6, it is VPN v6. You got it? Or should I explain you in another way?
No, I got it.
So,
Okay.
so Mr. Shank, I'm just trying to connect what you explained before to what you're explaining now. So, in the beginning of the class, you talked about multi-home networks, right? Where you had one router connecting to two ISP networks. So, I guess I'll wait for you to explain multicast later on. I'm not a subject matter expert, but I guess you would use multicast IPv4 address family when you have one router with one physical link connected to two
Doesn't matter.
ISPs.
Right now, let me tell you, doesn't matter how many routers or ISP you are connecting. We are using IPv4 with unicast. What is I told you in the beginning? BGP version 4. Okay. When we are talking about IPv4, it is unicast by default, unless until you run the multicast family. So right now we are only talking about IPv4 unicast. It is nothing to do with your multiple routers or multiple ISPs.
Okay.
Okay. So again, the diagram that I draw in here, let me draw it in another way so that you guys cannot not confused. So just give me a second. So AFI, we have first of all, the first AFI is IPv4. Okay. Inside IPv4, I have unicast, I have multicast, I have VPN, V4, VRF. Okay. Then we have IPv6, where we have unicast, where we have multicast, and then where we have VPN, V6, VRF. Then we have L2 VPN, where you can do it either via unicast or there is a concept of VPLS as well. I'm not sure about where we can run it multicast or not. So I need to check related to that. Okay. So right now, Glenn, what we are doing is we are doing only this part. And to make you remember the things, always remember when we are using any address which is related to class A, class B, class C, then we are talking about unicast.
Okay.
And when we are talking about class D, we are talking about multicast. So in our world, of networking, we have three type of address, which is unicast, which is multicast, and which is broadcast. Okay, and then we have one more type. Anyone knows?
Anycast, IPv6.
Yes, anycast is also a type, but forgot about it as of now. Forgot it, please, because this will make you confused. So unicast is your class A, class B, class C. Okay, this is class D, and broadcast address is 255, 255, 255, and 255. In hex, it is FF. Oh, sorry, your MAC address is FF, FF, FF.
Broadcast is one too many, correct?
Yeah, that is something which makes you confused then. If I write 1-to-1 here, and if I write one to many, now you will confuse. Okay, I have one router which is connect to my two ISP. So it is multicast, but again, it is not multicast. So do not read these bookish things.
Yeah,
Okay,
that's why I was confused.
yes. So always remember this thing: class A, class B, class C, class D, and this is your broadcast address.
Yeah, because I think here we're just talking about the yep, I get it. Just about the
Now,
which
yes.
IP segment is applicable.
So now, right now, if you see what are the segments, what are the networks I am taking? 10.1.1.0, 1.1.1.1, right? 172.16, 10.1, 192.168. Okay, so if you talk about this is class A, class A, class B, class C. I didn't talk about 2 to 4. I didn't talk about 2 to 5. Class D starts from 2 to 4 up to 240. So this is what we have range of class D. And after that, we have class E as well, which is of experimental use, which is never used. But anyways, so now you got it?
Yeah, I think I have a better understanding. Thank you, Shank. I
Yes.
appreciate
So
it.
this one-to-one, one-to-many, these are for only CCNA students. When you are talking about CCNP and CCI, you need to think above that.
Yeah, that IPv4 and all that was helpful. Thank you.
Yes. Okay. So this concludes our address family. So
Hey, can you go back to that one more time, please? To your
yes,
last.
Louis, route reflector is another solution for IBGP issue. Sorry, yeah. You need to take screenshot?
Yes.
Okay. So let me just zoom out more. So it is good now.
Yeah, sure.
And forgot about anycast. We will discuss anycast when we use multicast.
Okay. Hello.
Yes.
Yes. So noticed,
Your
most
voice
of the
is breaking.
screenshots you've taken, most of them have not been included.
Most of them are
Hello?
normally, sorry, your voice is breaking. Can you write it in the chat, please?
Okay, yeah, I said most of the screenshot has not been uploaded.
So screenshots, these are the screenshot which you got it when you enrolled in the class. So those will be uploaded in our G Drive portal, which I will explain you in just 2 minutes. Okay. So before we wrap up for today's topic, as someone asked me related to load balancing, just let me give the basic of load balancing today, and then again in detail we will talk it about tomorrow. So you can do equal cost load balancing as well as unequal cost load balancing. Okay. So equal cost as well as unequal cost. Okay. So if your all attributes match, so again, this attribute I need to talk about tomorrow. So that's why I'm not taking this topic today. But anyways, attributes are your local preference, then locally originated route. Okay. These are one of the attribute, then your origin, your MAD, all that stuff, AS path attribute. So if all these match, then after that you will do the equal cost load balancing. Okay. And for unequal cost load balancing, there is a feature called DMZ bandwidth. Okay, so this is one feature which I cannot explain in just 5 minutes. But again, through this feature also, you can do unequal cost load balancing as well. So this way you can do. But again, in BGP, we are not worry about load balancing. It is always we need to prefer one path over other. That's why we use the BGP. So load balancing, you not find it in 90% cases. Okay. So let's wrap up of the topics for today. Now let's take 15-minute session of the questions of new students. Okay, what are the questions you have related to your topology and all? So let me, before doing the question, let me show you what we are doing. Okay, so if let me open it. Okay, so this is our topology, complete CCI topology. Let me zoom it so that you can see it. Sorry, this is our CCNP topology. Okay, CCI have a different topology. So again, we have a lot of sections and we are doing the BGP here on the right side. Let me open it in Paint so that let me explain you. Okay, so it a little bit crispy, but okay. So this is in this section, we are doing BGP attribute, local preference, AS path and MED. Okay, then in this we are doing EBGP. Okay, so that way we are doing the things. And here we are doing DMVPN. This is again for BGP. This one, right one, AS number 2. Then we are doing switching here. So we have a complete topology where in single topology you can do all the things. And EIGRP, OSPF also we are doing it here. Okay. So we are doing it. IBGP we are doing it here. This is IBGP.
So Shank, based on your real world experience, IBGP is done inside service provider network. Is that correct?
Yes, yes. So mostly service provider we use to from exchange the route from one place to another. Normally enterprise is not needed, the IBGP. Okay, and then guys, we have our complete lab workbook ready, which on over our cares, which is always 24/7 available on our high-end servers. So you can completely do the practices. So this is, if you see, we have complete routing lab here. There is MPLS, we have a different lab. Okay, so if I show you, this is, you have everything, your commands, your complete topology, where we configure the thing, then what are the commands needed to configure it, then your show commands to see whatever the configuration you have done. Okay, so these are the show commands and all that stuff. Then similar way OSPF, then this is BGP. Okay, so again, some of the key points also we mentioned is here as well. What are AS numbers, who allocate AS, what are the type, public, private, okay, what are the 4 bytes. So 4 byte I will take it tomorrow. So this is also I need to take it tomorrow. So again, yes, we have it. And then our lab, so this is our EBGP lab. Okay, then what are the configurations, then this is our show command. So this is our show IPBGP summary. Okay, this will show us what are the routes we are learning via our neighbor. Okay, then our forwarding table of BGP. So this is like the network we are advertising. This is the next hop. This is the metric value, local preference, weight, etc. So this is how. And then this is the routing table, and this is the BGP route I am learning in my routing table. Okay, then debug commands, Wireshark captures, everything is there. This is the Wireshark capture, we have it. So everything is there, and we will provide you via our portal. Okay, so we have let me show you the portal as well. First, let's talk about the syllabus. So if on this link, let me paste it in chat, you can go and do. Okay, guys, I'm not sure from how long I am on mute.
Just a few seconds, like 10
Okay.
seconds, 20 seconds.
Okay. So again, let me tell you, this is our OSPF syllabus. This is where you will get these 3 modules are of theory, and then these 3 modules are of lab. Then BGP, we have 6 modules of theory and then 3 modules of lab. Then MPLS, we have these 3 modules of theory, and also we have lab, which is not updated, but yes, we have lab as well. Okay, so this is what we have, the complete syllabus with topology and all that workbook and all. And then let me paste you the link of this. Okay, so now tell me if you have any question related to this.
The topics that you're covering in these classes, are they like for CCNP on core and RC and CCIE lab kind of combined?
I'm doing the combined, like whatever syllabus you have in NCore plus NRC, okay, and plus CCI. So all the 3, I am whenever I take the topic, sorry. So whenever I take the topic, I will cover it with all these 3.
Okay, thank you.
See, lot of topic even today that I taught you guys, those are also like some other topics are CCI topics inside that. Okay, so any other question?
So Shank, are you going to be doing the labs too, or are you just going to do the
So
theory?
for CCNP, what I planned is like whatever the labs you have, you can try to get it by your own. And if you got any issue, you can ask me anytime. We have our Slack group. Okay, this is our Slack group where we have all the students who are enrolled. Okay, and I will, as soon as I see the message, I will reply it as okay instantly. So this is how we will do it. Okay, and for CCI, I will do all the labs first myself. So by myself, I will do it. Okay, and
Yeah,
then
I got it. I was just curious because when you showed that OSPF, BGP, and MPLS, you had different modules for the labs. Are those lab modules for CCIE or are those lab modules for CCNP?
so some of the labs we have it for CCNP, some is for CCI. Okay, so that is what we have, and then you guys need to do it by yourself.
Hello, Shank.
Yes.
Yeah, I understand that we're running out of time, but I would have loved that you put us through or you explain some of the labs for us. Take for instance the switching HSRP, yeah, HSRP, VRRP. Yeah, so I saw the questions, but I wasn't clear to the direction where the labs, what I need to do or what I need to work on. So maybe if you can find out time and just explain. You don't need to do the lab for us, just explain what we need to achieve, the objective.
So George, you are in our Encore and RC class, right?
Yes.
Okay, so as you know, I already explained in our switching section like what is HSRP. Even the commands also I run it, right? And for switching, I done the labs as well. But again, if you have any of the doubt in any of the question in any of the lab, do just let me know on Skype and then we will take it together.
Yeah, all right, no problem. That's fine. Thanks. Thanks.
Sure, sure. Okay. Any
And
other question, guys?
you were saying earlier that because I missed the OSPF class, didn't know that it has already happened. So you were saying that you'll redo it, or
Yes, we will do
okay.
it, redo it, but we will do it for new students. We need to do it on weekdays.
Gotcha. Okay.
Because weekend I am completely packed on weekend.
Yeah, for sure.
And those from the old students need to join it again, though you are more than welcome. You can join it.
Cool.
Yep.
Hey, what are the things that we're going to cover? Like, to what length MPLS will be covered in this class?
So for the MPLS, let me tell you, your LDP, this is the first topic, okay? Your label distribution protocol. This is the protocol by which MPLS run. Then your VPN, okay? And your VPN related to your V4 and little bit related to V6 and then VRFs. Okay, and VRF light and your troubleshooting related to all these things. So these are the syllabus of CCNP, NRC and CCIENT. Okay.
Yep.
So
We will.
this is
Go ahead. Sorry.
intra VPN. Okay.
Great.
And then if we talk about CCISP, the other topics that we added, like the other topic that Cisco added, okay, is inter AS VPNs, then your layer 2 VPNs, your multicast VPNs, and
What about QoS?
sorry?
Say about QoS.
Yes, QoS, then segment routing.
Okay.
Some of the most stuff. So these are
Traffic
advanced
engineering.
topics. And yeah, traffic engineering, most important traffic, MPLSTE. Okay, so these are the most important. So
Once this class is done, we should continue the CCIE SP.
Yes, I am already CCI SP as well, so you can get the benefit out of it if you want. So we will try to get one more batch, which is we will talk about this CCI SP and these topics especially. Okay, and guys, you can go with these all these things works on your simulator, and also in CCI XP we are running with iOS XR as well. Okay, so we can cover that as well. So especially 12,000 series of XR. So again, that is of later topics. So again, for this class, these are the topic of interest. Okay.
And for the MPLS, we will do the lab as well. That's on us.
Yes. We will do the lab. And also guys, one more batch that we are running. So which is our ACI. So this is what we starting. So this is
Shank. You should have started class on the weekend, man. The weekdays on my work time. It looks like a really good class you're going to teach.
Yes. So again,
I
this
agree.
is
The timing needs to be improved a little bit, Mr. Shank, because that's
so,
just like.
but again, for the timing, let's talk with the Sagar and with our backend team. So let's see if you guys having whatever the suggestions, if any of the good suggestion we got it, we will change it. No problem. But again, the problem here is Sagar is also taking a lot of batches, right? So again, those and some of you guys are enrolled in those batches, so that will clash. So that is the issue. So we designed it to keep in mind so that no batch can clash with each other. But again, if you have any suggestion, let us know. Again, one more combo batch we are launching, so which is ACI. Why this C becomes so? Okay, so one is ACI, another one is SD-WAN, and third is Nexus. Okay, so this ACI we are starting from 24th of May. Nexus also we are starting from 24th of May. Like our backend team will put it, the link related to this. And SD-WAN we are started on 6th of June. Okay, and again guys, this is weekday. This is weekday and this is weekend. And this is from 11:30 p.m. IST. And this is again 11:30 p.m. IST, and this is 9:30 p.m. IST. So
Yes,
this
that's
is
yeah.
this
So
is
Mr.
one of
Shank,
the batch we are starting.
so Mr. Shank, do you plan on doing the ACI Nexus in the future when we finish our CCIE for us in the weekend?
Yes.
Thank
We
you.
will do it.
How
But
long is this
again,
class going to be for? ACI?
right now we not have any plan related to that. But again, we will make it. Okay. So again, every class is of 1.5 months, 1 to 1.5 months.
Oh,
Okay.
that's a big plus, yeah.
Yes, because in ACI
Yeah.
we will do DC ACI. This is the exam
Can
name.
you shift that maybe to morning India time? That's evening US and UK time, US and Europe time. Maybe more
So
people with them.
I will talk with the Sagar and then we can discuss on that.
Because as you can see, that's broad in the middle of the day. I mean, in some of the time zone like US, Europe, and that makes it very. I mean, everybody's got work at that time.
Mm-hmm. So we will talk related to that. And so guys, for that, let me give your vote related to that. You guys can email on the email ID networkjourney.com@gmail.com. Okay. So on this mail you can give it, and then we will try to fix the timing if you guys having the issue with the timings and all. And SD-WAN is good. Okay, so this is on the weekend 11:30 p.m. So that is not a problem. That will be morning time for you guys. And again, this is a combo, and if you want to get a single class like Nexus or SD-WAN also, you can take it, or ACI, whatever your choice, because these are the three complete different topologies, not technologies, which are not dependent on each other. So any other question, guys?
Yeah,
For
Shank,
the
the
next,
ACI
sorry, go
and
ahead.
Nexus, are you still going to do the same approach like the CCNP where we
Yes.
have labs to play around
Yes.
with in EUNG?
Yes.
Okay, awesome.
But again, for ACI and Nexus, we are running with the simulator, so you have some of the limitations. Okay.
For the Nexus class, are you just kind of going over? I guess what are you basically covering in that Nexus class?
So we have a complete syllabus. Our backend team will give you the link right now in chat.
Okay.
We have a complete. So if I open it here, let me open it for you guys. Okay, I need to find the course, but again, I will paste the chat link on the chat.
Yeah, no
So we have
problem.
a
Thank you.
complete syllabus. Any other question, guys? And you will get all the lab access. For SD-WAN, it will be a limited access for 300 hours. What you got is 50 hours daily. Okay. Okay, guys. So if you not have any other questions, so we will wrap up for today class. And after half an hour, I have my SD-WAN class. So those who are enrolled, they can continue. Okay. And guys, tomorrow also I am taking the BGP second day. So those who are interested in OSPF, BGP, MPLS, please remember to enroll it today itself, so that you can miss it, because today class is the only demo class. Okay, so I got the link. Let me open the link for you guys. So previously this we has added the SD access as well. That's why it is 4. But right now our gear got stuck in COVID. For SD access we need a physical gear. So that's why we dropped the SD access as of now. So later on we will do it. So ACI, this is our complete syllabus. We have it, in which we have 6 of the theory class modules, and then we have our labs. And then we have as our complete SD-WAN as well, with our complete labs as well. So this is our SD-WAN. And then we have our Nexus available with the labs as well. So labs, we are running Nexus 9K as a model. Okay, so any other question? So these are the timings of the batch as of now, and we will discuss on the timings later on. So any other question, guys, related to this?
That works. Thank you.
And I have done the demo class of this SD-WAN today. So you get the recording on YouTube. And tomorrow at 9 o'clock Indian Standard Time, ISD, we have the demo class of ACI and Nexus. So those who are interested, they can join tomorrow morning at 9:09 a.m. IST. Okay. So that will be demo class for these two. Okay. So thanks a lot, everyone. And let's meet tomorrow at the same time in our encore class.
Good class, Mr. Shang. Thank you so much. Good class.
Yeah. Thanks a lot. Thanks a lot, everyone.
Yeah, thank you, Mr. Shank. Thank you.